All right, 4 hours. 4 hours of game dev or of coding. 4 hours and 4 minutes. Then 30 minutes of game dev. All right. I figured out this. I found this dark reader that this guy gives. This website prompted me to use one that's different, and it actually works. Because before, this is just terrible. But one that I had made everything dark, but it also made it only black, white, or gray. But this way, it actually keeps the colors. So, yeah, it actually enhances the colors and contrast. That's good. Yeah, I can read everything. Fuck yeah, dude. Alright. Okay. Okay. Why? Or they're named and literal constants. I don't know how a literal constant would be. I mean, it sounds like any literal that I do is a constant because unless I can access that temporary variable, but I feel like I can't. So I don't know anything about literal constants right now. Because I mean, if I did like gravity and I did it within a global scope and I did um, float gravity and then list initialize it as 9.8, that'd be a named constant, not a literal constant because it has an identifier. So I don't know how we're going to do literal constants, but I guess we learn it literally next time. What's literals? So maybe all literals are constants because a literal is a literal. Like I do standard character output and then a string high. Well, that string high, that sequence of characters is a constant. I can't do it and then go back and then get it. It was a temporary variable. It's probably destroyed after it's used. So there are different types of named constants. Constant variables. Different constants. Okay. Or three different. Okay. Types of named constants. 3 ways to define a named constant. So one way would be those object-like macros, so defining something using header guards, or not even really a header guard. I mean, it's really kind of a condition. I mean, I guess it's like a condition. Why isn't that what it's called? They're called conditional preprocessor directives. So it's conditional. It happens before runtime, so it's the pre-processing. It's actually, isn't it like before or it's during compile time, or maybe even before, and then directive. So shit that's happening, things that we're telling the computer to do. So if I had an if statement and stuff executes depending on the if statement, but I had an if not defined, then define, or if I had if defined, then do this, if def, if not defined. I think I can do if defined, if not defined, different things. So if we say if defined, then I can run shit. Well, if it's not even defined, then the if statement, the conditional, is false and doesn't run anything even before the program is able to be run. That's before execution. Versus other conditionals are after or during execution. I'll need to shave. All right. They're constant variables, so we name a variable and make him const. Enumerated constants. Unscoped enumerations. I don't know what enumerations are right now. Best I know is like drop downs. Constant variable, like mapping a variable to something else. So like 1 is a word, 2 is another word, 3 is another word, and like splitting. But that's kind of like a macro, which we haven't really used very much. We didn't really define something and then use it and then replace it, because that was a thing I could use macros for, but we mainly just used it for header guards. Constant variables are the most common type of named constant. So we'll start there. Okay, constant variables. So far, all the variables we've seen have been non-constant. Okay. Yeah. Yeah, true. Also true. Hmm. Oh, okay. Yeah, maybe you don't have to worry about the memory fluctuation, but it is just using a piece of piece of memory. So, isn't it the heap? Just using it. It's not getting popped on or popped off the stack. It's just being created and it's just there. Variable whose value cannot be changed is called a constant variable. The one an oxymoron? Hmm. A const qualifier. Why did you say adjacent? Why wouldn't you say before? Oh. Never mind. That's why. Adjacent is all that matters. What if I could do const? Well, I'll find out. Let's see. So we do. I don't even need this. I think, is it in input output? Oh, is it because standard int is in that? All right. Okay. Seems like input output includes standard int. Okay. Oh. Wait. Oh, maybe that's why. It's C. Oh, okay. Versus. Oh, still doesn't work. Okay, yeah. I'm pretty sure that's what we're supposed to do. C, standard int. Oops. Okay. Oh. Well, the question is, can I do a constant? Looks like I can. Oh, whoops, because it's an int. Whoopsie. Oh. It doesn't actually care. So, it doesn't care about me using it. That is interesting. It only. So, const variables don't need to be used, seems like. Wait, isn't there like a maybe unused thing? We never used that. What does this look like? Oh, good search bar, dude. Okay. Place it adjacent to the type. It'll accept it before and after. It's much more common to use it before. Yeah, it makes sense. Constant something. Green ball, not a ball green. Yeah, dude. English, best language. Oh. Oh. This style is called East Const. Isn't that the same shit? Oh, that is East Const. Okay, cool. Just because it's to the right instead of West Const. Still sick, almost not sick. Or at least I feel I'm getting better now. Headache's almost gone since work is over now. Just from being sick. Okay. Oh, the type is a const double. Oh. So what would happen if I'm wondering what would happen if I static casted something to be a const something? So if we had int, just int x, whatever. Int x, and we made him be 4. Oops, that was stupid. Okay, we have int x. And then what if we do... Oh! Cool. I can do that. So that's the type. It does not give a shit about spaces for the types. Noted. They must be initialized when you define them. Oh, I'm curious. What happens then if I... Oh. Oh, I didn't give it a fucking type, yo. Oh. Oh, we're not doing output yet. We'll just do... Oh, I can't. We'll just do X. Apparently not, buddy. Apparently fucking not. Constant X. Oh, it has to be defined, but we can define it as 0. The problem is we can't just declare it. So what if I did that? Const requires initializer. Const requires initializer. Okay, cool. If not extern, I don't know what extern is. Okay. Must be initialized, and that value cannot be changed via assignment. Oh, it could be assigned somehow else. Yeah. Must be initialized when defined. So, oh, okay, good. I forget he's not value initializing here, so this would be an error. And here, we can't change him. Well, this wouldn't even work. This would get stuck here. But assuming he value initialized or did something else, he can't assign. Cannot assign new values to him, allegedly. Can't be changed, it says. They can be initialized from other variables, including non-const ones. Yeah, so I could have like, oh, whatever, height is 60, and then height is 62. But then we have const, max height, and we set it to 64. That way we know that he doesn't grow any bigger than 64 inches tall. 5'4", baby. Sag. Okay. Say enter your age, you're this age. We extract it to store it. We then say your const age is your age. And then we say age can change. So we say, oh, you're 2. Okay. So we say const age is 2. But then we say age is now 5. So now age is 5. And then we say const age now gets 6. Oh, can't do it. Because const age is a constant, and constants can't change. Const variables can't change. We initialize it with a non-const. Because it is still const, we can change its value. But that is const. Cool. Hey. The initializer of a const can be a non-const. Oh, fucking duh. You don't have to just do a literal, buddy, because apparently a literal is a literal constant. A number, or there's a number of different naming conventions. Okay. Underscored uppercase? Oh, hell no. We'll just do K. Okay. Why? Yeah, that makes sense. I agree. Thank God. K is better, but it's still stupid. The name, the identifier should tell you whether it's const. Earth gravity, const. Player height, maybe const. Human height, at time, not const. Parameters, const. Function parameters? Function parameters can be made const. It takes a constant x. The point is that once we pass in a value, we can't change it. And then the value's gone. And then we pass it 6. And 6 is constant. We can't change it. Excuse me. Yep. Because that's how variables work, buddy. That's how parameters work. Yeah, makes sense. Yeah, true. I mean, I guess if you were passing at a oh, that is why. When we learn about pointers later, we're probably going to learn that I've got like this snot that is just hard, or this boogers that the liquid is just hard on the hairs. It's poking out and pricking me and it hurts. I almost just reached for chapstick for my nose. I need to do lotion in a bit. So here, if we were doing references later and we're passing a reference to a variable to something, it might be good to pass it a const reference. That way I get the values, but I don't actually change what's there. Unless I want to. Okay? But that's only when we're passing by reference. But because we're passing things by value, it doesn't matter. We're not... If int x there wasn't constant, and we'll say we passed it a variable instead, well, it just gets a value of the variable. It gets a value. The value of the argument is passed to the parameter, not the actual or argument, because then the argument could be changed if it's a variable or an object, I guess maybe. Ask one question real quick. Man, these people at work are fucking lying, dude. We had chicken fried steak because my generous supervisors or managers, I guess, manager and then director, paid for lunch using work funds. And got chicken fried steak. And the people there were saying, you 100% got your daily dose of sodium from that. But according to that, the max, let's say it was double. Even if it's 3,600 milligrams, one, I could still go higher and be fine. Depends on the body, but apparently 3 to 5 grams of sodium. The highest I just saw was literally half the minimum daily dose. So, and that was the maximum. So even if it was double, it's still within the daily range. Plus what I ate today, still within the daily range because I had rice, none, I had a fruit, or a tomato, cilantro, chicken without too much. Let's say it's 1,000 there. Okay. So we're at twice the max, so we're at 3,600 plus 1,000, 4,600. A tiny bit in the oatmeal this morning, and then I'm gonna eat some more of the same shit later. Dude, maximum. I could eat that chicken fried steak every day, probably a lot more, and still be within the daily value. Man, these people are crazy. All right, so we don't make value parameters const because we don't care if we change the shit. The const also adds a small amount of unnecessary clutter to the function prototype. Okay. Yeah. Well, oh, see if you can hear that. Chairs squeaking. Okay. I don't know if we care about the unnecessary clutter. I mean, you could just say it's unnecessary. The clutter part doesn't really matter. I mean, because, well, it doesn't benefit us. So it's not the clutter that's the problem. It's that it's not useful. It's like, if you're going to give me a lamp for my room, I might use it. But, or a statue in my room, it's just not useful. I don't want it. And there's clutter. So I guess it's both. Also, yeah, whatever. You're saying it's both, so fuck it. Noted. Don't use const qualifier for value parameters. Value parameters versus reference parameters, I think. Later. Oh. Oh, multiple. By reference and by address? Really? I only know reference. I don't know address. Oh, so it passes a constant value. For fundamental types, but this is is this specifically talking about when returning by value? Then the const qualifier on a return type is simply ignored? Because why would it matter for why would it be like that for fundamental types? Because if I was returning a character and I don't want to be able to change that later, I'm basically creating a variable here. Oh wait, but I'm not instantiating. Well, what if I was on a return type? Oh, but I guess it's returning the value. So it doesn't matter. I'm returning the value of something. I'm not returning the constant value because this isn't this variable. This value is stored temporarily, which is assigned to this. If this wasn't const, it gets this value, which is for some reason const here, which it doesn't need to be. And it gets 7, and 7 was a const variable. But now I can change it because this motherfucker's not const. It's technically temporary, so I can't access it anymore. But if I did some variable and then we assign them to be get value, then if the variable is constant, then the 7 that was constant in this variable, or in this return temporary variable, couldn't be changed. But if it's not constant, then even if we give a non-constant something of the value of something that was constant, then it's still changeable because we're not passing it by reference. We're not saying, hey, you are now this reference. We're not passing it the variable. We're passing it a value. Make sense? So for fundamental types, the const qualifier on a return type is simply ignored. Yeah, because we're returning. Yeah, because fundamental types are not references. If I return a fundamental type, by definition, an int, a character, a boolean, a void, a float, those are not references. Because the reference is a type, I think. It's like an int reference or something like that. A reference to an integer variable, I think. So a constant value doesn't make sense because we're not passing a reference, so it doesn't need to be const, so it's ignored. And for other types, like other objects, when we're passing it by, when we're returning by value, then we're returning temporary values of the actual, of the object that was in the variable. So we don't need to make it constant because it's a temporary thing that's destroyed anyway. Look, and it's verbatim what this guy says. Pre-watched. It can also impede compiler optimizations. Okay. Well, because it just does more shit to it. It's more careful about. So if something is constant, can't be changed. So maybe in the meantime, just like a bank, if I put $1,000 in a bank account, the bank can use that $1,000, but it also has to give it to me whenever I request it per my contract. Especially if I give it a bunch of money, they can use it. So sure, while I can go there and get it at any time, maybe it's passing other shit there and swapping and stuff. So if we call those move semantics and compiler optimizations, and instead of making another temporary variable, maybe it just uses this variable to store it for a second, and then, I don't know. Excuse me. But if we do constant, then we can't do any of those move things. I'm basically saying, yo, my bank account is untouchable. You can't use it to pay other people and do shit in the meantime. It's got to stay what it is. Money can't leave it unless I tell you. Actually, I can't even tell you because it's constant. So don't use const qualifier when returning by value. Okay. Why variables should be made constant. If it can, it generally should. After telling me 400 reasons to not. Cool. Yeah. Oh, because maybe if the const variable doesn't change, then if it figures out how much memory it needs, maybe it doesn't need to anticipate using more, or is able to use less of it because it's figured out in the beginning. Like I say, hey, I might need 16 square feet to do this. But then once I order and I start using that square feet, I only use 8 square feet. The guy using it will be like, yo, you're not using the rest of this 8 square feet. I'm going to go back to use that. Yo. So if I say in advance I only need 8, then he can actually just give me 8 and maybe cut the room down to size. That way it's just less shit to sort through when I actually have to go in there. So returning a const value can impede some things. because it has to worry about not changing that temporary value, which means maybe it has to do more shit, which takes up more processing, more memory or something. Maybe not more memory, but more, I don't know. I'll turn the time off and just check, see what happens. Can't I turn it off? Thought I could. Not fucking Edge. Wait, isn't it like time and language? Yeah. I thought there was a way. Formatting? Nope. Fuck. Did I swear it was here? Oh. Bro, where? Oh. Yeah, that'll do it, buddy. Thanks. Okay. I'm not gonna hide it. I just need to be better at it. Don't put the candy out of the room. Just get some fucking self control, bro. Just stop caring about it. Like, I'm not dreading any of this. I just look at it. I don't know. I just look at the time. I don't want to, though. Hmm. Yeah, it makes sense. It's just extra shit we don't have to debug. Hmm. Yeah, it makes sense. Just less. I mean, that's what they say. Fewer moving parts, bro. Basically, so right now, don't make any, but at some point. Oh, substitution text. I forget that I've been defining stuff and then substituting nothing. So I haven't actually been using it to substitute it. So I put in define my name Alex, put in my name, and it replaces with Alex. That's because these are another way that you can name constant variables. The substitution text is a constant value, so we can't change it because it has been defined. It's been defined. It's object like. Object like, because I'm defining it as basically an object, but it's been defined and it has substitution text. It's not necessarily initialized as something, so it's kind of like it. It's like thing with a value, but it's not really in it. It's kind of just that they're tied together and unchangeable. Like I can't undefine, I don't think. Why not use them? Three major problems. Biggest. Oh, macros don't follow scoping rules. Mm. Yeah, that makes sense. The more conflictions. But the confliction would be substituting something you didn't actually want to substitute. So it wouldn't be a confliction. It would just be, oh shit, why is his name still popping up as Alex? Oh, I defined it earlier, and this is still the same program, even though it's a different function. It's still the same file. Hmm. Oh, because we. Oh, because it's So the compilation error is that we've defined gravity to be 9.8, and gravity is 9.8. Excuse me. So we have gravity as gravity is the parameter, and then we print gravity, but then we're passing it in a value to replace gravity, but gravity has already been defined as a preprocessor macro with substitution text. Object like preprocessor macro with substitution text? That's a long ass time. Object like preprocessing macro with substitution text? God damn. Versus variable. Constant variable. Sorry. Prog. Let's try this. We'll do some output. Define whether sunny. Cool. All right. And now int fuck. Define gravity. We got define height 64. Because it's a statement, right? Oh wait. Oh, yeah, it doesn't even have to be a statement. These are just extra. Yeah. Okay, and then later on we say, fuck, we don't need sunny. Oh, it's because that's why. Oh. Yeah, there we go. Uh-oh. If I do that. So if we don't do that, but if we leave it, what if I do this? Cool. If we do that, I'm initializing a variable here. What if I just say this? Oh. Yeah, it's gonna think that he's missing constant. Interesting. GCC? I don't know what that is. Something clang? Go good clang? This confusing error, it expected something before a constant. I don't know what those, well, so what, it was having the issue on line 17? The issue is that we've already defined something, and then later on, we're passing values to a variable, or to an argument, but that argument is actually a const, so it can't be changed. So it says before a numeric constant, and the numeric constant looks to be 3.71, but then it says line 5. Wait, what? Define gravity 9.8 in expansion of macro gravity. So it seems like expansion of macro gravity with macro, object like preprocessor macro? Object, yeah. Preprocessor macro that's object-like. That is a constant thing as well. Constant variable. Named constant. It's not a variable. Excuse me. But we're replacing this guy. We're basically redefining him later to be double gravity. Yeah, so like if I had that, and then I just did that, it has an issue because the motherfucker, this guy already exists. This guy's going to get replaced, but he's a constant. So if we did constant float height, he's still upset because we're replacing this variable with this, and it's its name. So, I don't know. Okay. It's hard to debug code using macros. It will have the name. The compiler and debugger will never see the macro because it has already been replaced before they run. Damn. Yeah, because it's pre-processor. So it happens even before compilation? It's not IDE only. Hmm. Ah. Yeah, it makes sense. Behaves differently, hard to debug, and they don't follow scoping rules. So they replace shit you wouldn't expect. Which makes it easier to make mistakes. Times two. And they behave different, so they hard to debug. Constant variables have none of these problems because normal scoping. Other things do behave like them because they behave like variables. They just can't be changed. And they're not any harder to debug, I would figure. Oh yeah, because it's hard to debug because they don't see them. Oh, I think the issue is actually, in my case with the definition earlier, it's because the name of the variable was 64 point whatever. It's a literal. So we were making a const double, or a double 64.5. Like, what would happen if I did that? Yeah, that's fine. So that's this error. This is a constant. If I give it copy or value copy initialization. But then we do oh, so this works. So we're changing them to Y. So this is Y and this is Y. Okay. So the issue is when I'm passing a variable to him, but he's already constant. So we do this and we call him 5. This needs to be the value, not the variable name. So this guy is 5. And no, he's that. Oh. No, it would be the variable name. So if we did this, and then we had a function, and it'll just be called return a double, and we'll call him return gravity. And then we'll have double gravity. Gravity 9.8. And this and then we say oh, oops, can't output stuff. So this guy goes to 9.8, so this guy is now 9.8. Double, but it's 9.8. Isn't that kind of how it was used earlier? Yeah, because we defined him as 9.8. So this guy is now 9.8. So we have double. His name's 9.8. Define gravity 9.8. It's just fucking weird for now. It's just fucking weird. That's fine. It's fine. Well, that'll be one of the things that I learn more when I need to. Okay. For constant variables. Okay. Needs to be used throughout the whole code. Okay. Well, it seems like I can just do it in a CPP file because variables and functions have to be inline in order to be defined multiple times within a program. So if we just define it once in one, we should be able to get it, I think. Yep. Makes sense. Yeah, so I have some file that I include everywhere, some implementation file. I mean, the header might make sense. But it doesn't even, no, the header doesn't even matter because I don't need to include it. And if I include it, it's being defined twice. So we actually don't want them in a header file. We want them in a regular ass CPP file somewhere. Sharing global constants across multiple files. Ooh, using inline variables. So there's different ways. Nomenclature. Type qualifiers. A type qualifier makes sense. We're qualifying a type. We're making some kind of addition and behavior modification to a type. Const used to declare a constant variable. It's called a const type qualifier or const qualifier because it's a type qualifier and it is a const type qualifier. So we give something a const type qualifier. As a C++, it only has 2 type qualifiers. That's it. Const and volatile. Shit. Can have its value changed at any time? What in the fuck is it used? Oh. May have its value changed at any time. So, don't optimize them, I guess. Don't use them to move shit around either. It's kind of like const in that regard then. It disables certain types of optimizations. In technical documentation, they're referred to as CV qualifiers. Who the fuck knows what a CV is, though? Curriculum vitae. Excuse me. Oh, tomorrow's Friday. Let's go. I'm gonna play one game of Osu just because I want to.
Welcome to us.
It's fine. I just want to. Oh, 2 stars is too hard. Why did it lag me? Fuck. I was trying to do between beats. Fuck. Nice, that was fun. So these are type qualifiers. Okay. So volatile. Oh, maybe I do that. I do a tiny little song at the end of each lesson. That'd be kind of fun. But I don't want to do that because then it incentivizes me for finishing faster so I can do songs faster. Not really. I only get to do it once, so maybe not. CV qualifiers. Because constant volatile. That's what CV stands for. Okay. Constant volatile qualifiers. Them together. Oh, deja vu. Them together are often referred to as, should be the CV qualifiers. A CV unqualified type is one that doesn't have either. A CV qualified. Oh, could you have const volatile? A CV qualified has one or more? Okay, one or more would be constant, but does that mean const volatile? Well, what about that? Let's find out.
Let's find out. Don't need this.
Const volatile int x 5. Oh, well, we're not using them yet, so we'll do. What am I gonna do with them? I can't. X, I guess. Oh, yeah, that makes sense. Pop. Oh. Wait, what? Oh, we're not outputting. Okay. It can be const and volatile. Noted. Possibly, maybe, or maybe not. Why? Why would I need this? You can appreciate this joke from JF Bastion. How do you know if a C++ developer is qualified? You look at their CV. Oh, bruh. That's pretty good. Okay. All right. Well, I did my Osu song a little early, so I'm gonna do one more, and it's fine. It's fine. I'm allowed. I'm gonna do a quick one though. Wait, it needs to be 2 stars. This isn't 1 star. This isn't. Oh. Oh, I know this voice. Why? The numbers are changing. Sort by difficulty, bro. What? Ew. Alright, now it's sorting properly. Okay, cool. Oh, that was too fast. Wait, what? Why is it changing? The numbers are changing. 2.28 to 1. I need a fast, short one, dude. Oh, this is terrible. I want actual music, kind of. I want... Oh, it is the Wakaki band. That's cool. All right, we'll do this. Oh. That's kind of hard. Don't know what I did. Still suck at this mode. It's more fun though. Song sucks. Oh. Okay. Literals directly inserted directly into the code. 5 is a literal, integer literal, a boolean literal. The true, because we're initializing it using a literal. We're initializing it using a literal. We're outputting a literal. Excuse me. Double bool, int, string, C style string. Wonder what C++ style is though. If we even do that. If there's another type of string. Oh, isn't it? Isn't it like standard string? I think we do. Curious what the answers will be when it explains why, or when he explains why he introduced C style strings instead of C++ stuff. Even though we started with the standard character output from the beginning. I think I want this to be fucking tighter. Okay. Just want to loosen up more. Just because I'm sick. Weak. All literals have a type. Yeah. Makes sense. Yep. Oh. I guess you wouldn't necessarily assume that, but Booleans can only get, well, yeah. I mean, Booleans can only get Boolean values. But a character, what would even happen? What would happen if I took a bool and I initialized him with like something weird? Oh. Oh. Because it's taking whatever the ASCII code is, the integer version, because that's how it's stored. So we're trying to initialize bool using direct list initialization as something that's outside 0 and 1. So it does take a narrowing conversion because we're losing information or data. Well, look at that. Videos are going. Fuck. This one's taking. Oh, it's checking. Yo. Yo? Okay. They have types. The type is deduced from its value. Okay. Character double, floats, const. Oh. Const character 14. I wonder what the 14 part is. 1, 2, 3, 4, 6, 13. Oh, because it's -1, so maybe. I don't even know anything about C-style string just yet. So the default type of a literal, I can add a suffix? What? Oh. Hmm. Yeah, I don't know any of this shit yet. It's different than the percent shit from C. S and SV require an additional. What is it? Standard include standard string or include string or something? C string? Oh, and that's here. That's soon, dude. Let's go. I like learning all these things that I actually see people do. What the fuck happened to my taskbar? Oh no. There we go. I don't know how that changed. I screwed up. On my other monitor, it had big ass previews for all the stuff I had open. Like, it'd be the little Chrome thing, and then it was big, and it was over here. And then this one was big, so Chrome was pushed here, and this one was big, so this V code was here, and this is here. Like, what the fuck? Okay. Complex numbers and chrono time literals? What the fuck does that mean? Oh, chrono literal? Yeah, chrono makes sense. I mean, it's a chronograph. Well, chronograph doesn't. Well, it's velocity during a period of time, or its position changes over time, so chrono, I could see that. Isn't chrono cross? Or chrono trigger, it has to deal with time, so chrono. Isn't Chronos the god of time or something? Yo, why are my eyes just watering? It's like they're just sliming up. They're not even watering. Except in the F suffix, they're most uses when deduction is involved. Deduction for type deduction for an object using the auto keyword. Oh yeah, we used auto a fucking bunch before. I was using auto all the time when I was learning C++ in the beginning. The guy was this guy on the LinkedIn learning shit. He had exercises and quizzes, and it was cool. I mean, I remember some stuff, but I mean, it wasn't as cool as reading. But then again, I wasn't spending so much time on it because I kind of just watch him, and I don't watch. It's hard to watch and then pause and then go and do something because videos always have extra shit. Like nobody has a video. Nobody goes over literals and then says this could probably be a video. Literals, and they have types. And then they have suffixes. And that's it. And I can read this in like probably a minute if I wasn't talking out loud, but I was still kind of locked in. A minute or two. But a video would be like 5 minutes on this. And there's never like a distinct section to section in a video because it's not organized like this. I mean, maybe there's a timestamp or there's like little, I don't know what they call them, sections or something, pieces. But it doesn't feel this organized. It's not like a page of a book and then another page of the book. It's always kind of continuous. So it feels like I can't get out of it to go and learn the next thing. Like here, I'll learn this and be like, oh shit, let me go and do that. Because I finished reading it and I see that there's next shit here and I can see that there's a next distinct section instead of letting him kind of drone on a little bit. And then I might practice this, but not this. But here I practice all the shit. Okay. So accepting the F suffix, suffixes are usually used when doing deduction. Autos. So like auto X, and then I initialize him to be 5. It's probably going to say that he's an int. And he was like, yeah, try and use auto as often as you can because whatever. I mean, I guess basically just let the language figure it out for you. Maybe there are reasons. I mean, it sounds like there are reasons for it. Class template argument deduction. So there's a template, and it's a class template, and it's argument deduction. So it figures out what arguments it's going to have. So like a class takes this, but then you have a template. And depending on the class it gets, because it could get multiple classes, it has to figure out the types it gets. So depending on what you pass it, it has to figure out what class it is. Interesting. But maybe not, because it's figuring out argument deduction, it feels like. And deduction guides. That's cool. What does that even look like? I'm going to click that real quick. Uh-oh, here we go. Oh, it feels like I just stepped into something that is way too high level. Oh. Okay, not doing that anymore. Oh, we did the suffix before, because we had to do it for, well, we had to say float specifically, but then if I wanted something to be treated as a float, there was some way that instead of just doing 5.0, I actually just passed it. Oh, it was because I did double, or no, I did float. And if I did float and then 0.1, was it a narrowing conversion? Because I'm losing some of the precision. There was a reason there. I think it was like truncating. Let me see. So we'll just have a float named Mofucka, and he gets 0.1. And we'll just say Mofucka, and then we'll say return. See? We're truncating, we're like converting, or whatever truncation is. We haven't really talked about it. It sounds like conversion, type conversion. From double to float. So it's not necessarily a narrowing conversion, I guess. Maybe it is. And it's a warning, not an error. So we're changing it, and it wants to make sure, yo, are you actually doing that? If you do a static cast. So like I could do here, I could do that, the suffix, to change the type of the literal, or tell the compiler what type the literal is. Or I could do static cast to a float, and it's 5.0. Boom. Because then we're casting that literal to be a float instead of its default type, which is a double. So most suffixes aren't needed except for F, because because the compiler, or I guess the language, defaults to floating point values being doubles, just I guess for the extra precision, feels like. And to reduce the frequency of errors by probably a good bit. Type deduction. Okay. So now it's not making noise, the chair. I don't know why. Well, it probably has to do with the tightness. Most of the suffixes are not case sensitive. Not case sensitive. So we can do L or big L. Okay. The exceptions are S and SV. Excuse me. Oh, SV is string and then string view. No clue what that is. 2 consecutive must have the same. So it's LL or this. Because lowercase l can look like 1. Oh shit, true. Wait, it really does. Wow. I mean, the fix would just be to remove the top and bottom left parts of the line so that it just looks like that. That's how L should look. Boom, boom. Boom, boom, or boom. Like that. No hook on the top left. I don't know why there's a hook on the top left. June it up a little. Oh, alright. Dude, this fucking nose, man. Just being sick sucks. A lot of shit have been blown out. Oh. That's probably why up here is trash. I'm probably actually blowing some sort of snot type stuff up here. Because I'll feel my eye like move a little, or like this little bit open up or something. Because I'm blowing air out. But like maybe a little bit of snot's getting in there, and that's why it's harder to wipe compared to regular ass water in the morning from waking up. Oops. Go. Go. So, prefer to use uppercase literals. Others use lowercase except for L. Yeah, I agree with that. Whatever. Oh, never mind. Prefer uppercase. Okay, capital F. Well, you didn't do it later, buddy. In chapter 13, you fucking did not. You were using lowercase, bucko. Generally won't. Except... Well, generally won't, but here are some examples. No suffix is default int. And then long, and then unsigned int. Yeah, makes sense. Most cases, it's fine to use non-suffixed, even when initializing non-int types. Well, yeah, it's believable. I mean, I guess unless you're doing like a big one and you're doing it to a short and you run out of memory. But types match, automatically converts. Dude, everything is all messed up. Into an unsigned int because it's within range. In most cases, you're not doing a negative though, yo. In the first case, we're cool. In the second case, it doesn't match the type because that's an int that's unsigned int. The compiler will convert 6 into the unsigned value of 6. Ugh. Ugh. In the third case, 7 is not a long. It's just an int. Cool. Converts it. Maybe that's that truncation converting. Truncate. Floating point literals. Default to literal, we have to do F. Oh, good. You're already not using F anymore. Oh, good job. No suffix, it's a double. Suffix is a float. 6 to 8, usually 7 significant digits, I guess. Oh, my legs are freaking... Dude, this feels so good. I'm stretching my... like right under my hips, the part of the quad, the tippy top. Oh, that's good. I've been doing some squats at work, just sissy squats. And I do it whenever I get water. I fill my bottle up and I just do a bunch, like 10 or something. I mean, they're not hard. I mean, I'm a light dude, so they're not hard. But oh, I haven't been doing shit. Oh yeah, I haven't even been stretching. Didn't do my exercises today, so I guess I'll do it. I'll see if I can do it while I'm doing this. Be more active, not just don't just sit. Why it causes a compiler warning? Well, yeah, because you're taking a double, or you're initializing a float as a double, and you're using direct list initialization, brace initialization, so it's going to catch that narrowing conversion. It doesn't necessarily say narrowing conversion here, but it feels like that's what it is. Double to float. Oh, there it is. It's right here, dude. That stretch. Oh, and there. Man, I'm gonna be a new fucking breed in like 2 years. Once I have some C++ under my belt, I'll be 27. Go and work for a place, make like what? I mean, I'm hoping for that 160. But if we're making like 90 grand, I'm just saving. I'm making 40K more than now. Even on the taxes, I'm saving like just 25 grand extra. Easy. Probably 30. Yeah. If I'm paying 25% tax, if I make an extra 40K, I'm actually making a 30K. That's 30K in the bank yearly. Over 20 years, 600K plus interest. Bro, I'm bukuing. I'm bukued. And my expenses are going to go down because my rent is 16. With other stuff, about like $1,700 of rent per month. Well, yeah, it's actually, yeah, because the electricity isn't included. So it's like 1620 plus that, all that. Just because I got an apartment at a bad time and did it out of convenience, which is stupid. I'm still saving, but not nearly as much. I save like $550 a month instead of saving, a grand. So, which would be 20% gross, which would be way better than 20% net. Oh. It doesn't match. Literal must be converted to a float first. Implicitly converted. It can be used to initiate F because F is a float. Can result in a loss of precision because we're losing significant digits. So this is a warning. Well, feels like the first one is definitely the answer because I'm not going to change the type of the variable. I mean, I guess both of them are equally valid because the answer is, hey, do I need a float? Like, do I need to explicitly do this just for memory? Do I need to put float instead of double and do the F? If I change it later, I have to remember that it is an F because it's not an auto. But if it's an auto, maybe it determines that because an auto will say, hey, only 2 digits. Maybe we do float instead of double. I don't know. I did stretch on this side. Okay. What's next? Use F so literal is a float. It matches. Yeah. Or just change the type. I mean, both are valid. Does it make more sense to use a double? Is it just a waste to do a float? Are we so memory limited that we can't do a double? I don't remember the size of a double, but yeah. Two different ways to write floating points. We have regular or sign notation. Yeah, so you could do 3.14159 E0, but that would be retarded. Yeah, can be negative. Because it's not unsigned. If you can even do that. I don't think you can. Can you? No. Yeah, true. 0, 0. Okay. And then I'll do the harder ones in a sec. It's time to apply some of this. So we need some output. We want float, gravity. Oh, 9.8. Oops. And we want flow Avigaddy daddy 3.02 E23. Excuse me. Standard character output. I love gravity and Avigaddy daddy. Best numbers ever. Pop. Cool. Wait, how did it output that? Okay, it actually still does output it as E. A string literal? Collection of characters used to represent text. Names, words, sentences. Dude, sitting actually feels so much better after being active. Wow. The very first program. Yeah. Let's just write that just for no reason. We need some output. That's my program, buddy. Hello world. Give me some dedicated wham. Let me watch that. Dedicated.
I was wondering, what's the
It doesn't make any sense. He says wondering, and the R is so perfect.
Next question on this left side.
I was wondering,
Wondering.
what's the recommended
But then says what?
amount of dedicated wham I should have to a server?
I'm sorry, could you please repeat your question?
Dedicated wham to a server.
RAM.
If you're
how
running
much
off your
RAM?
PC.
Percy. Dude, the dude is tripping.
Oh, okay.
It's dependent on plugins and players.
Yeah, it's a, what it's really this is a technical question you're asking, how much RAM?
Fuck, why? Seven years, it's 11 years now? Damn. S- 64 bits of thermal paste. Alright. It's just stupid. Okay. Yeah, that's our program. I mean, I guess you could do return 0 right after, but whatever. I like having a split because, you know, ending. So we do this, blank, end, return this code. Do something, run calculation, return that bitch. It's not do this. It makes it feel like these are connected. It's just weird. It's like if we're returning early, this return. I guess if we do a calculation, position, whatever, return that. I kind of just like having a space between return stuff, unless we're returning early, maybe. Hello world is a string literal. They can be placed between double quotes as opposed to character literals, single quote. Yep. Oh, good. Oh, there we go. Now we're getting it out. Sorry. Implicit null terminator. Okay. Yeah, it makes sense. Oh, that's why to see oops. That's why this had 14. Because terminator. Implicit null terminator. 6, 7, 8, 9, 10, 11, 12, 13. Terminator end. Backslash O 0. Nice. Sorry. Oh, so to get 0. Hmm. Oh, because they're called escape sequences? So this guy's an escape sequence. Seems like we're getting or escaping from the regular functionality of 0. Special character called a null terminator, and it's used to indicate the end of a string. Oh, okay. As opposed to a string that doesn't end with 1? Yep, makes sense. Yep, makes sense. Bro, why'd you put this twice? Null terminated string. Okay. Unlike most other literals. Huh, const objects. Okay. They're const objects that exist for the entirety of the program. Meaning that they don't go away? They aren't just temporary values? Okay. The values, it seems like, are... I mean, it feels like they're stored within temporary objects and then discarded, but maybe not. But literals are values, and they have type. They're not objects. But these are start objects that are created and are guaranteed to last the lifetime of the program. Wow. Oh, but those are C-style string literals, so it's probably not the case that you actually want to use later on. So C-style string... We don't know exactly why, but it will tell us why. Why C-style string littles are constant objects. But these are constant objects too, but they're temporary. And maybe they aren't even constant. Must be used immediately. Oh. Seems like that's what I would want for most of my shit. Because right now, it's created at the start of the program. So I start a program, and at the start of the program, I am using some memory, going from using this much to this much. Just a little bit more. to instantiate and I guess initialize this guaranteed full program's lifetime C style string object. C string object. And it lasts until the end. So we go up, and only once the program ends we go down. Instead of, ooh, local variable, he's used. Oh, he's destroyed. Oh, local or C++ string, whatever we call it, standard string view. Oh, using him. Oh, he's gone. That's what we want. We want to use shit only when we need it. Man. It seems like we want to use. Well, I guess it depends. We want to use shit only when we need to, so that we have more memory to use other shit. Unless the burden of using and unusing the shit is bad. Like if it fucks with the frames, maybe it takes more memory to have all this shit loaded in. But we load a bunch of stuff in the beginning just because the computer's not fast enough to load all the stuff in dynamically, like shaders. Oh, and then on Sunday I have to do laptop coding again and no game dev. Well, actually I could do game dev. Yeah, I could do that. Oh wait. Yeah, I'll do more laptop coding because I'm going to do it while I'm at a house. Or I might just chill and do D&D actually, because I can come back and then do C++ after. So I can chill more on the weekends, but I kind of still want to lock in. I want to see if I can lock in more. I need to keep doing this, that way I get disciplined enough and learn it as a skill. Because like Tokyo Spliff says, people were asking him before how he could stream doing C++ monotonous kind of work. I mean, it's not super monotonous because he's making his own game engine and making his own game straight in C++. So it's actually like making a game. I could make a game for hours on end, but learning coding, I can now, but not as much, maybe. Intuitively, it's just not quite as fun. Well, it's not as fun because I'm not doing shit. I'm learning stuff, but learning stuff isn't as cool as just doing things that are, I don't know, it's cool. I like making things go bang and seeing them. There's no things going bang here. So, I like making things that go ching and slash through and you hear the flesh. Slashing a sword against a goblin. That's what I want. Oh yeah. Blood on the screen. That's what I need. But he started streaming, did like tiny little streams, hour or two, couple hours. And then later on, now he's doing like 12-hour streams every single time he streams, which is like every few days. He said he just got better at doing it. Didn't have to pay attention. You just do it. It's just discipline. So just lock in, bro. Temporary objects must be used immediately as they're destroyed at the end of the full expression in which they're created. Okay. We discuss them later. Magic number. Oh, hell no. An unclear meaning or may need to be changed later. Magic numbers? Max students per school. It's a constant, and it is initialized to be num classrooms times 30. Seems like 30 is an int, and then we can set max, which doesn't have to do with anything, which is also 30. But I don't know what the... Oh, it seems like they're both int. It seems like they're both ints. Max students per school, so it's classrooms and then times the students. It's not immediately obvious. We'd have to go look at the function to see what it does. Oh, magic number. Oh, okay, makes sense. Yeah, we just don't want to use magic numbers. So make a variable and then use it instead of magic numbers. I understand. Yeah. So magic numbers. Set max to be 30. What is 30? Why not just have a thing and we call it max students? And we set max students, we value initialize it to be 30, and then we set max to be max students. That makes sense. In complex programs, it's difficult to figure out what the fuck a literal represents unless it's a comment to explain it. But then you gotta add a comment instead of just doing the identifier. Bad practice. No context. Problems if it needs to be changed, because I don't know where it needs to be changed, what to. I'm trying to get better at that in my own Unreal stuff. Excuse excuse me, like the last one I remember was movement speed, storing it at 600 instead of manually having to add or set 600 as the default move speed. Buys new desks, and that allows them to raise the class size from 30 to 35. And our program is to do that. We need to do 30 to 35. But which literals? The 30 of max students per school seems obvious. But what if that's num classrooms times 30? Well, it's classrooms times students. That's students. Okay, so it seems there. But what is set max? A global search and replace? You might inadvertently update set max when it wasn't supposed to. Oh, because you change it to be... Oh, because you search for 30, and then you replace it to be 35, but in reality it wasn't supposed to change, because 30 was actually how many pencils are in each student's fucking thing. Box, class, desk. Yeah, oh, fuck. Oh, don't tell me that. Oh, no. No, sir. By using symbolic constants. Oh, okay, we're just setting it to be a const because it can't change. And then, well, if we need to change it later, then... Oh, we just can't change it in runtime. Okay. So if we're doing a literal, we know that the literals are constants. So if it's going to be a constant, I may as well just do a fucking named constant, which we could call a symbolic constant. 30. Cool. Max name length. Oh, shit. Bro, if your name is too long, you're done. It's over, buddy. Makes sense. Ah, okay. -110, 0.0. Oh yeah, just +1, we're incrementing it. Well, I mean, you could just do ++, so it's better later on. We're starting it with 0. In context. Ah, okay, because they're doing kilometers to meters. Multiplied by 1,000. We could also have a variable, a constant variable, and we call it meters per kilometer. Avoid magic numbers. Used const expr. What is expr? Expr? Oh. They're not even const expr variables. Okay. Symbolic constants. Oh yeah, because there were types. Oh yeah, because this is all about literals. Okay, cool. Why do they have the same suffix? It's still able to differentiate. Well, yeah, motherfucker, because one doesn't have a floating point, one does. Bro, these people are AI. Why is it a common source of compiler warning? Because the default's double, motherfucker. Hello? Oh my. Oh. It shows you comments for the lines? Is that right? Where is he seeing this? This guy's just fucking yapping. Who knows? These are all uploaded now, I think. Okay. If the default type for an integral, if the default for integral type literal is int, why am I able to compile the following code without a narrowing conversion? So you're saying there's a short and we're doing 1. You don't even have to fucking increment it, yo. Whereas this code results in narrowing conversion. So we do this. For what? Oh, because we're... Oh shit, here we go. The top conversion is a different type. Can be done at compile time, whereas the bottom conversion is done at runtime. Oh. So it's convertible to a short without data loss, so it's not considered narrowing. The bottom is not that kind of conversion. So a const expr conversion involves an actual literal. Const expr. Const exprs are resolvable at compile time. It sounds like numeral systems. Ooh, get to learn hex again. KO. Alright, I'm doing a song. And then I'm gonna do my harder leg exercises when I'm after this. That's a good song. Oh, nice, live. Oh, I almost missed that. Ah! Getting better slowly.
See you next time.
Okay. Okay. Sounds good. This lesson is optional. Meaning, do it. Everyday life, we count using decimal. Oh. 0 to 9. Fuck. I'm still... I guess I need to use this. I'm not good enough to approach the ground. Base 10 because there are 10 possible digits, 0 through 9. Okay. Okay. Numbers are decimal. But sometimes they aren't, sounds like. Oh, excuse me. Falling. Falling. Instead of being 18, maybe. Oh, 4, 6. Or, wait, that wouldn't even be binary because it's 2. Can't even tell if I'm cold or not right now. Excuse me, I think I'm hot. Oh, base 2. Zero, 1, 2, 3, 4 is 0, 1. And so there's zeros, or so there's, oh, so it's 2 but to the power. So it's 2 to the power of 0 is 1. And then 2, so it's 1s, 2s, 4s, 16s, 64s. 64s, probably 2048s. Or no, more than that maybe. Yeah, more. Two digits. 0 and 1, base 2. Okay. Yeah, because then we have 4 plus. Oh, God. Or it's 4, no 8s, plus 16. 16 plus 64 plus 128. Or, sorry. 16, no 32. Yeah, 64, 128. Yeah. Decimal and binary are numeral systems. Four main ones. Octal? Why would you use that? I have no clue. Never even heard of octal. Gotta be. Okay. We got numeral systems where we're using systems systems of groups of symbols or individual symbols to represent different numbers. Yeah. Dude, okay, I have to use a pillow. There's not enough cushioning for me to not slam the ground. Decimal binary hex octal. Oops. Ten, yeah. 10 is how many tens you've got. 110 in that. But it's 1, 2 in the next. Yeah. 1 plus the last, which is 1, so it's 2. Yeah. The regular names are there. Wonder what you call them in octal or in hexadecimal then. Shit. The fuck? Octal is base 8 and 7. So we count. So you get 13. So you get 13. Yeah, 13. 14, 15, 16, 17, 18, 19, 20. 23. Why the fuck would you ever want that? Prefix your literal with 0. 012. So 1, 2 is 8 plus 2, which is 10. Could have been a better counting example here. So this is 1, 2, 3, 4, 5, 6, 7. And then 8. Oh, that's why. 7, 8, 9, 10. That's why. Okay, so it's not you're skipping. It's just that the numbers are represented different. Okay, it's not bad. Never mind. I was being stupid. Octal. Oh, good lord. Need some output. That's 11. Because the leading 0 doesn't change anything, so. Hmm. Oh, good. We recommend you avoid it. 0, 1, 2, 3, all the way up to 9. A, B, C, D, E, E, F. Oh, okay. 9, 10, 11, 12, 13, 14, 15. 16 is 1 0 because it's 1, 16 plus 0. 17, 18. You can also use lowercase, 0x. Okay, so there's 0 for octal and then 0x for hexadecimal. Okay. Need some output. Need a function to do shit. Fuck. I'm not gonna know this. 4 plus 64. Oh, fuck! 17 plus 16 squared. $160 plus 36 is 196. I think plus 60 again, so 156. 156 plus 17. Is that right? Wait, what? 16 times 60. Wait, what? Oh, because there are 2 of them. 16 times 16. There's 2 of them. Oh, good God almighty. Makes sense. Okay. Yep. My brain was already ignoring the 0x shit, which is cool. It's like, okay, it's F. A is 10. Noted. Yeah, this is way better. Why would you use caps when you can use lowercase, dummy? Hmm. Yeah, they're all actually okay. Yep. Hmm. Let me say it's 4 bits. 16 different values for a hexadecimal digit. For 1 digit, a single hexadecimal digit encompasses 4 bits because bits are binary. So how much does F encompass? It's 4 individual bits because each bit is a... Fuck, what is a bit, bro? A binary int, I think, isn't that it? A binary integer? How many binary integers does it encompass? 4. So a pair of them would be 8 bits, and that's a byte. A 32-bit int would be long as shit. In hexadecimal, it's a lot better. Just because they're in 4s, so we just group them by 16. Say, fuck it, if they're really big, we do 16. So we group every pair of 4 into 1. Yeah, so every 4 binary, which is already how binary is separated and organized, it's 1 digit. That's way better. Hex is used to represent memory addresses or raw data in memory whose type is none. Binary literals? No support for binary literals, so useful workaround. 1, 2. What? Oh, okay, we're just literally counting 1, 2, 4, 8, 10, 20 for just reasons. Who knows? Excuse me. Well, I mean, is it more clear cut? Not really. It's not super clear cut. The conversion between binary and hex. You could also just say that assigning regular fucking ints, regular int literals, or assigning binary to a variable. So, if I had just done 1, we would have done that. If I had just done 2, we would have done that. Oh, but that's C++. Okay. 0B. 0B1, 0B11, 0B1111. Okay, whatever. Excuse me. Need some output. So we'll do 8, 9. What? Oh, what the fuck? Why did I do that? I don't know why I put 3. What? Oh, because it's 1. Oops. That's 9. 0B. So there's 0. Octal is 0? Oh, nah. 0x is hex. 0b is binary. Digit separators? Oh. That's kind of cool. Bro, that's not a quotation mark. That's an apostrophe. We can't do commas because we aren't those weirdos. Need output. Oh. Cool. What if we do that? Oh, well, duh. Well, what about here, though? What if we do it only in the beginning? Uh-oh. Oh. It thinks there's a character or something? Can't use it before. Yeah, because then it thinks this is a character. So. Okay. Can't be before. 0 is binary. So this is 2 plus 48 plus 128. Okay. What? Standard. Sorry. Oh. 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 Need IO stream for output. Is it just standard hex? Yeah, I think so. It's a standard bool alpha. What if we do then standard decimal? Also, it's fine, so I should be able to just swap. That's 16. Decimal. That's 10. Octal. That's 8. Oh, so 10. Oh, what the fuck am I saying? 10. How do I display 10? It's 8 and then 2. How do I display 10? It's A. How do I display... Oh, wait. Oh, it's decimal. And that's A. Okay. I guess it does it lowercase, too. So hex is not case sensitive. A and big A, same shit. Oh, blew my ear out. Oh, GG. Okay. Yep. Bit set. Oh, hell no. So I have to give it a value that fit. Well, I mean, I guess it's the same for integers too. This is the type. This is the value. I have to make sure the value fits here. But it's harder here because I actually have to know exactly whether this will fit. Like, I don't know what that is. So I guess that's 8, and then 16, 32, 64, 128. So a standard 2 of these guys is 128. There's 16 per. So. So we get bit set for the binary printing stuff. Include need output. Bit set. And we set the amount of bits. And it's size T, 8 bits. And we initialize them to be 8 bits could be up to 128. So we'll say 120. Yeah, 128, I guess, right? Oh, we have to name him. That's the type. And his name is binary num. Binary num. Yeah. Okay. Makes sense to me. Oh, and I guess for every hex I'm going to put in there, it's just 2 times, or it's 4. So. But there's no easy conversion between decimal and that. So I could see how it could be useful, I guess. Oh. Excuse me. And that's a temporary binary version. So instead of actually giving it a label, we can just leave it a literal. So normally if I just do 4, that's an int without a name. But if I do bit set 8 something, then it doesn't have a name. It's just binary. It's the binary type number. So I could do include bit set for the binary stuff. Stream for output. Bit set 8 bytes, and then just initialize and be up to 128. So we'll just do 155. Yeah, because it's 128 plus that. Oh, okay, so I guess it can actually fit more. Because it can fit... Isn't it almost double? I think this fits 255 or something. Like how the numbers align. Oh, yeah. Because that's how it is for all of these. So this is just one more than the max of this. This is one more of the max of this. This is a 4. This could be a 5. Oh, hold on. 0s, 2s, 4s. So this is 1. This is 2. This is one more than that. So if this is one more than all this, and this is 128, this is 64. Or sorry, 127. So this could be 255. So we could do 255. Let's say it's a big ass number. Then it is all ones. Cool. Binary's not so bad. Create a temporary unnamed bit set, which is a binary object with 4 bits. How much binary? How much memory? And how much binary? Initializes it. Prints the value in binary, then discards it. Yeah, makes sense. Covered in more lesson. Like, oh, bit manipulation, cool. We could choose which bits we're doing shit to. Outputting values in binary. A new format library and the print library. Oh shit. The fuck is this? Formats the argument as binary digits. Oh, instead of doing bit set and then passing it, OB whatever the fuck. Because we're doing binary and binary is not the easiest, we have to do bit set. Instead, we just format something, some sort of text. So we're outputting text. This piece of text is formatted. It's formatted to be binary. And then the inline operator, for some reason. Binary inline operator. And then the next one is... the number is binary. Oh, and this is print line. So print and then go to another line after. And we print binary and binary with the literal shit. And then binary and then binary with the literal shit. As OB pre or 0B prefixed. Okay. I don't know any of this shit. We need format. We need include format, include IOStream, and then include print. And then we need to format some shit. What are we going to format? Oh, oops. What? So what am I using? $20. Dang. So, just know some stuff. Oh, okay. Or just in your brain, bruh. Ten can be whatever you want, man. It can be 10. It can be 2. It can be 8. It can be 16. I can format some shit. Binary AND operator. Or binary with the binary format. What do we call this? Binary prefix? 0 prefixed? Format. IOStream. Because IOStream is the main shit that comes last. Because it was made earliest. It's the oldest back in time. It's the oldest. More shit relies on it. So we want to catch those errors earlier. And incompatibilities earlier. Okay. Well, yeah, because we're not passing it anything. So its parameters are different. This has parameter being void. Whereas in the declaration, it has the parameters being something else. So it thinks this is another function. So it thinks we're overloading. We ran out of names. Format. The initial, the curly braces, and then B, or it's this, B, and line. And then, I don't even know if it's a comma or not. We do 01, 02, 01. Fuck. Is it? Oh, it's semicolon? Fuck. Character? I don't even know. Bro, what is it? The fuck? Oh, it's... It's in quotes, curly braces, colon B, and then end line. What? comma. What were you fucking around about before? Expects this where? Oh, before constant? So it's thinking call to immediate function is not a constant expression. Yeah, I don't know. The answer is the fucking getting the arguments right. And then we can do this to get the OB. Oh, but it's not OB. Oh. Oh. Doesn't even need to be OB. It just puts the OB. Oh, shit. You didn't even need to put that there, bud. Okay. 32 in binary in hexadecimal. In binary, 32. 1s, 2s, 4s, 1s, 2s, 4s, 8s, 4 zeros, 16s, 32s. It's 1 followed by 5 zeros. And in hexadecimal, it's 16 plus 16. So it's got to be 3 digits. So it's 100. So it's 1 and 5 zeros and then 100. Fuck. It's just 2 16s. I forget that we're not limited to binary. Oh my god. I can't learn multiple numeral languages. Numeral, what are we calling them? Numeral systems. Oh my god. It's 0s, 2s, 4s, 8s, 16s, 32s. So it's 1, 0, 0, 0, 0, 0. Looks like 10,000. And then, oh wait, no. Looks like 100,000. Well, but it's really 10 and then 0, 0, 0, 0. And then in hex, 16, or it's 32. Well, 16 happens to be 10. So it turns out to be 20, 20, 20. The as if rule. As if. Holy. Got no clue about this. A lot of words on that page, buddy. What? So bad, dude. I'm so terrible. But I'm just learning stuff. It's like if you gave me a fucking program to write, and it was hard. I haven't played regular Osu in a sec. I'm gonna play one song fast. I'm gonna fail this. I'm gonna fail this, it's too hard. Oh, fuck, I'm playing games, I'm not even programming. I'm allowed to do this, it's okay. Just a little. There's no way I failed any of these. Oh, these are all crazy songs, this one. It's been a while since I played this game. Okay. Alright. Introduction to optimization. Oh shit. Making it work more efficiently. Huge impact on the overall performance. Yeah, tell fucking modern devs this, motherfucker. Dude, I'm gonna be better than devs after this. Wow. So game devs at least. Excuse me. And Google Chrome devs. Holy shit, takes forever to load. Yeah, you better get your profiler going, buddy. Yeah. Never seen that third version. Oh, okay. Oh. Yeah, I guess it's true. Yeah, it makes sense. Small gains, baby. Yeah, I'm done playing games on recording. That's a waste of time. Oh. Oh. That's cool. That's cool, because it automatically writes the efficient shit while we're focused on reading. I need water. Code that's modular. Okay. Been programming for minus the OSU time, 2 hours and 30 minutes. Still have an hour and 30. So I'm gonna pause, eat, and then resume because I need food.